Now enter Rolles' theorem. Same idea. Let's say we have two values, A and B, and these y values are at 0. Y equal to 0. So we could say f of A equals f of B. You agree with that? Okay. If this thing is continuous, is it possible to go from A to B without making a peak or a valley like this, a max or a min? Is it possible if it's continuous, not having a max or min? Yeah, by doing one of these. Okay, then it's possible. But if we make one little addendum to it, the slope of f of b minus f of a over b minus a, what will that slope be equal to if these are equal to each other? We could say 0. But if these are equal, it's going to be 0 over b minus a, or 0. In other words, there has to be a place between here and here where the slope is 0. And that's one. That's one. Here we've got two places. You can have as many as you want. But the idea is if it's differentiable on AB, you're going to have a place C where f of C is equal to, f prime of C is equal to what? 0. Or the slope of AB. And that slope, if they're equal to each other, the slope is equal to 0. So when you're setting these up, all you have to do is find the slope, f of b minus f of a over b minus a. Okay? Say that it's differentiable on AB. I think they have it not equal. Okay, so if it's differentiable on AB, there exists f prime of C equals 0. There has to be. There has to be a C where f prime of C equals 0 by Rolles' theorem. The better version of that is mean value theorem. The mean value theorem is the same thing. If your slope is f of b minus f of a over b minus a, we'll just call it the slope. And you're differentiable on A to B. That's important. No cusps, no skips, no discontinuities. Okay. Then there exists C where, are you ready for this? F prime of C equals what? 0 for Rolles' theorem, M for mean value theorem, any slope. Okay? And you would say by mean value theorem. Well, that totally doesn't make sense, does it? But back in the 50s, it made sense to police. Okay? Back in the 50s, they didn't have radar guns, and so what they did is they staked out two places. Let's say that you have two places 10 miles apart. They wouldn't go 10 miles, but we'll just keep it simple. Let's say a car is going 20 miles per hour at point A and 10 miles per hour at point B. Okay? We don't know what happens in between, but what we do know is the police can say, hey, this guy started at this time and he got to you 5 minutes later. So if the t is 5 minutes later and the distance is 10 miles, what had to happen? Well, if you got started here and you ended up here, I don't know what happened in between. I have no idea what he or she did. But I know there's a place where the slope equals m. At least one place. There has to be. If it's what? Differentiable. There's no time travel portals or any, I don't know, some huge machine hitting them back into time or whatever. But you can't, there are no cusps or anything like that. So what that means, there was a time when they were going how fast? Well, that would be 10 over, that's 1/12 of an hour. So there was a time, if they went 10 miles in 5 minutes, there was a time where they were going how many miles per hour? 120. Now, could you argue that there were times they were going faster? Yeah, a lot faster. Okay, but do the speeds at the beginning and the end make any difference? None. No difference. This 10, 20, and 10, they can be going any speed they want. It's the time it took them to go that distance is what is key. So if you're looking at a problem like, let's go do one. Let's do one right now. Your first one. Determine whether or not Rolles' theorem applies, and then find the values for where the derivative equals 0. So what you're doing here for Rolles' theorem, you go f of, here's your a, and here's your b, f of -5, and f of, really? 7/3? Ugh. That's really awful. But if you put those in, they turn out to be 0. I'll just give it away. Okay, they turn out to be 0. If you put -5 in here, it's going to turn out to be 0. I don't want to just do that in my head, but I know they turn out to be 0. So if both values, or wait, maybe they're not 0. Maybe they're the same y. Maybe they're not 0. Somebody do that real quick. I was right. 0. And when we put 7/3 in, it's 0. We didn't check it, but don't tell anybody. And so, therefore, these are both at 0. So here at -5, we have 0. And at 2 1/3, we have 0. Now, what does that tell you if these are the same? Is this continuous and differentiable? Is it? You bet. No denominator with an x in it, no weird square roots. So on -5, 2 1/3. All right? So then all you have to do is say the slope equals 0. So the derivative of x is going to be equal to 0. 9x squared plus 10x minus 43. I think that's going to work. And you should be able to find the x values that make that true. And this one, I think, is a cube, so I think you're going to have 2 of them. And then you can find those 2 values. We'd even call them c's. C is equal to something, C is equal to something. And then you're going to, for tomorrow, do B, C, and this number 2. And I think that should wrap it up. Where are those? Yep, and all the answers.